A person can afford $800 per month for mortgage payment. So how much he or she can borrow over 25 years at an interest rate of 11.5% per annum. So the interest rate is 11.5% per annum, or 0.9583% per month, or in terms of decimal that will be 0.09583. So this one will be the monthly interest. Now the amount that will be owed, so let's say the person can borrow p dollars, and the amount owed by that person after first month will be p 1 plus r, which is 1.009583, and then the amount returned is $800. So that is the amount, that is the mortgage payment the person can afford. So that's the monthly installment. And then after second month it will be p 1.009583. This will become square, and then 800, this will become 1.009583, since the whole thing is multiplied by this much, and 1.009583. And then the second month's less the second month's installment, and this way it will go up to, since this is over 25 years, so the total months will be 25 into 12, which is 300 months. So it will go up to 300. A 300 will become P 1 plus 1.009583 over 300, and then minus, this one has one less, so it will be minus M 1.009583 over 299. This is getting clumsy here, so I will write the bottom line. So that's minus M 1.009583 to the power 299, minus, this way it will go on, and then M 1.009583 and then minus M, like that. So A 300 will be 0. So on one side it will be P 1.009583 to the power 300, and on the other side it will be M, and it will have actually, so I will just write that series again a little bit, 9583 plus up to there 1.009583. maybe I should have taken just two terms anyway. So this will be 299 again. Now there will be, in this geometric series there are 300 terms, because the first term does not have the power of 1.009583, with in the first term is 0, and the last term is 299. So in total there are 300 terms. So that's there, P 1.009583. It's actually better to write 1 plus r while we are doing the formula, and finally we can plug in the values, probably that way it is easier to write. But anyway, this one, the first term here in the geometric series is 1, and the common ratio, so 1 is there, I'm not writing 1 is here maybe, and 1.009583, there are 300 terms, minus 1, and then 1.009583 minus 1, so that will be 0.009583. so M is actually 800. So why did I write M anyway? So I will write it 800 because I have been writing 800 throughout. 800. Oh, I have written M here as well. Anyway, so basically M was 800, but M is actually instead of M here. That's good actually. It doesn't look as clumsy. But finally I'm plugging in all the values except P is the unknown, the amount that is borrowed, and once we solve it, it becomes, so basically I will write it here again. It's 800 times 1.009583 to the power 300 minus 1. It's very important to write the expression properly in a calculator, because otherwise we will get wrong result, of course. And then times 1.009583 to the power 300 here as well. So once we plug in these values in the calculator, the result we get approximately is 78,700 to the nearest 100 actually. So this much amount the person can loan if he and she can afford $800 mortgage payment per month. So that is the amount the person can borrow.